Hello and welcome. Following the introduction of our home platform and .edge product, we are very excited to explain the next step in Lawo's vision for modern broadcast infrastructure. It is clear that the industry is experiencing an intense transformation. A few years ago, most systems were built in a static way. But now the industry is evolving towards flexible workflows and dynamic use of tools. This is largely driven by the demand for agility in content creation. To meet these demands, your modern infrastructure needs that same flexibility. It can be good to have a lot of fixed functionality, but it might make your infrastructure too rigid and make you unable to respond to changing demands. We see real benefit in flexibility, enabling you to quickly adapt as your needs change.
A modern infrastructure consists of 3 layers. Starting at the bottom, we have the edge layer. This comprises of stage boxes, I/O connectivity, routing panels and control surfaces. The middle layer, which we refer to as the fog, is your local data center, your machine room, or your technical rack in your OB truck. Essentially, it's where your processing is located. With most customers today, this is pretty fixed. The upper layer refers to the public cloud. Connecting your I/O from the bottom layer to the processing in the middle layer is mostly done using low latency production formats. These low latency formats, such as 2110, require high bandwidth. Moving into the public cloud and the internet provides you with the ultimate connectivity, allowing for more diverse remote productions. However, navigating the public cloud requires different technologies which are typically lower bandwidth and can overcome the unpredictable nature of the internet. Last but not least, it is very important that you can manage this infrastructure in a modern and simple way. Lawo developed the Home platform in response to all of these needs. Up until now, Home has been used to manage the edge layer.
Let's recap. All of our devices, both audio and video, are automatically discovered by our Home platform and presented in the management UI, living nicely together with third-party home devices or any other NMOS device. Once you select a device, you can modify all parameters, for example, changing IP address, create streams, control internal shuffling matrices, and of course, monitor all the parameters from any device. Let's have a look at this audio stage box. In the audio stage box, I've got a complete overview from all network ports, all the transmitters, receivers and internal routing. Of course, I could also select one of the processing cores, a UAG core. In the UAG core, again, I've got all parameters available. Or we could also look at one of our video devices, a .edge blade, which could be my video stage box. If I select my .edge blade, I've got a complete overview from all parameters. I can again go into the network ports, transmitters, receivers. I could actually even take a look at all the SDI connectivity. Finally, I can also operate my infrastructure by connecting any source to any destination in our stream routing page, as you can see here.
Today, we are taking Home to the next level and adding processing. This is the next step in Home's evolution, enabling you to spin up a function when you need it, where you need it. Let's take a look.
At the top of our device list is a new App button. This allows me to spin up different functions. Let's start by creating a multi-viewer. From the moment I start to build this multi-viewer, Home will present me with reasonable default values, but I can tailor them to my specific needs. As you can see, we can define the maximum amount of pips within the multi-viewer. We can set the output resolution of the head from SD through HD all the way up to UAG. And even more important, our multi-viewer supports not only 2110, but can also handle compressed formats such as NDI, JPEG XS and even SRT. These formats can be used on either the input stage or the output stage. Once the Multiviewer app has been created, it is immediately shown in my list of devices. Be aware that the Multiviewer is configured, but not using any processing power yet, and therefore not consuming any energy. The next step is to spin it up. I select the Multiviewer app and I activate it just when I need it. In the stream routing page, you notice that all the inputs to the head appear as destinations and the head output appears as a single source. Let me simply connect a few video and audio streams into our existing Multiviewer. And now let's connect our head output to the screen standing right next to us. Within seconds, we went from nothing to a fully functional Multiviewer. Of course, this is not the full story. We also need the ability to modify the layout. To do so, we use our existing configuration product called the wall. Within the wall, we can modify any parameter, going from padding, border colors, adding PPM metering, adding clocks, text fields, or we could just load a complete different layout.
But that's not all. If we stop an app and then restart it, the configuration is stored. This means that we can stop the app when it's not in use, saving compute resource and power. Let's now create a UDX. A UDX offers up, down and cross conversion, and in this example I'm going to perform a conversion from 720p to 1080p. As with the MV, during the creation process we get the opportunity to set the output resolution and the desired format on both the input and output stage. Once created, our UDX is immediately added to the device list. Let's spin it up. I'm now going to route an input to my UDX and route the output to the monitor. As a home native device, our UDX has built-in parameter control. To demonstrate this, let's overscan the picture. Now you'll probably be wondering why my conversion looks a little washed out. Well, that's because I've routed an HDR PQ source, which we are currently viewing on an SDR monitor. Fortunately, our UDX has the ability to load a 3D lookup table, allowing us to perform HDR processing from HDR PQ to SDR. I'm now just going to select the right lookup table. Now you see the picture looks as expected. And finally, our UDX has one last trick up its sleeve. If I now enable my graphics, we have the option to overlay graphics on top of the video.
In addition to the Multiviewer and the UDX, we are also introducing a stream transcoder and a graphic inserter. The stream transcoder allows you to transcode 2110, JPEG XS, NDI and SRT in any direction between any of these formats. The graphic inserter can insert HTML-based graphic into a video stream. Let's take a look at how all of this magic just happened.
We spun up processing on a generic server. Lawo has developed a range of functionality in the form of apps. These apps consist of a number of microservices which are packaged and deployed in software containers. We only ever deploy the containers necessary to perform the required function, ensuring we only consume the required quantity of compute and power. A container bundles together software, services or applications with all the required dependencies as a package, making it easy to deploy. Dependencies include binaries, libraries, and any required configuration file. There are many benefits, including boot speed, scalability and portability, security, efficiency, and it's very easy to change version at the press of a button. Whilst Lawo has engineered a solution using key cloud technology, it doesn't mean we have to run our apps in the cloud. A user is free to run on-premise, in the public cloud, or a combination of the two. The same philosophy applies to the whole home platform. Let's take a look at what happens on the server when we spin up an app. The home platform talks to the app container manager. The manager reads the template for the requested app and deploys the required containers. Each app resides in a processing slice. A server can host multiple processing slices, performing compute tasks on CPU, GPU, or both. We can scale up our processing capability simply by adding more servers.
So what type of server is it?
Home apps can run on Intel or AMD CPUs, with or without GPUs. We do require a specific NIC to maximise the interoperability of our 2110. This essentially ensures our packet distribution and timing is good. Not all servers are equal. Some offer much more compute performance than others. Lawo will help demystify this and provide tools to manage deployment, preventing oversubscription.
Home apps are incredibly powerful and open endless opportunities for you, helping you to be more flexible and more able to respond to changing demand. This was the original promise of IP, now realized.